All right, ladies and gentlemen, good morning. We're going to run through what's called a discriminant today. The discriminant does a couple different things for you. It's going to tell us what kind of roots we have, whether they're real or whether they're imaginary. It's also going to tell us if they're going to be rational, meaning like either nice whole numbers or in fractional form, or if they're going to be irrational, those decimals and kind of gross, and we need the quadratic formula for. So this is kind of a nice little picture of these different things that you can see. If it is our discriminant is b squared minus 4ac. It's just the stuff that's under the square root, which makes sense, right? So if the stuff under the square root is a nice number that can be square rootable, and we'll have a rational real number. If it ends up being negative, less than 0 down in this pink section, if it's negative, that means we won't actually have real roots. We'll have those imaginary roots, and we know we'll need to use the quadratic formula. Or if it's 0, we know it's going to be, there's one root, and it's going to be the only one on there. So we'll see a couple different types of those, talk about what we would use each part for, and then you're going to try a couple today. So you can pause this and take a peek at this if you'd like, but essentially the biggest point of this is we're going to use this right here, b squared minus 4ac, to figure out what kind of roots we can have. Sometimes that's the only information you need. I don't really need to know what the roots are. I just kind of want to know what kind of roots are going to be. Should I expect to see real answers or not? So let's just do that part then. So the discriminant, if I still need a is 3, b is -8, and c is -3, we're still going to go through and we're just going to do b squared minus 4ac. So we're just going to kind of plug these guys in and see what happens. Okay. If I plug this one in, it just says I'm going to get -8 squared minus 4 times a, which is 3, times c, which is also 3. Okay. We'll grab our calculator. You can put it all in at once. 8, -8 squared minus 4 times 3 times 3. Okay. And I get 28. I get 28. Oh, I dropped a negative here. I was like, I shouldn't have. Let me try that again. So sorry, 8 squared minus 4 times 3 times 3 times -3. Goodness. Good morning, everyone. Yeah, that makes more sense. Good. So we get 100. That's what I expected to get. Good. We get 100 when we do this. Okay. So what does this mean? It tells us a couple different things. So our discriminant here is greater than 0. Okay. It's positive. Right. Greater than 0. It's a positive number. So that tells us our answers, our roots, our solutions to this equation are going to be real. We're not going to have i's. We're not going to have imaginary numbers. They are going to be real. So that's good. Okay. And it also tells us we know that when I see 100, I know that the square root of 100 is 10. So not only are these real, they're also rational. And why is this nice? Well, that means I can factor this if I want to. Okay, we could still use the quadratic formula for it, and frankly, we're halfway through almost with the quadratic formula. So you might want to still use the quadratic formula, but you also might notice that, hey, this is factorable. It's factorable. I could do 3 times 3 is -9. What adds together, or what multiplies to be -9? That adds to be -8. Oh, that's -9 and 1. It probably would be pretty easy to factor. So if you like factoring, this is a great problem to factor. And that's what this tells us. That's why this is so nice. That's why we might use this. Okay. So we would write that you could factor this or quad formula. And importantly, you can have 2 real solutions. Okay. So this is what I'm going to want you to write on your assignment today. I want you to write how many solutions there are. So this is one, there is going to be 2 real solutions because it's bigger than 0. It's a positive number. And I want you to write that you could either factor or use the quadratic formula on this. Cool? There's another thing that can happen. Okay, let's try this guy. If I did this, we could run through, and my A here is 1, my B is 10, and my C is 25. Okay. So if I go through B squared minus 4AC, I'll do 10 squared, 4 times 1 times 25. Okay. What do I get? Well, if I do 10 squared minus 4 times 1 times 25, I will get 0. And this is a really special case. So this is what happens when we actually have exactly one solution. Exactly one solution. It's 0 underneath the square root. So then when we add and subtract from 0, we're actually not going to change it. So this is the case where we get one solution. Or if I think about what I'm looking at, it's like my vertex is right on here, and that's the only point that touches it, is my vertex here. So you would write one real solution, okay? And you could factor or so once again, I don't need you to actually find the 2 solutions. I want you to find the discriminant here. Okay, these are the 2 things I want you to do. I want you to find the discriminant, what is it, and tell me what it means for your solutions. Second thing that can happen, or third thing, I guess, is like this. You'll get be it that if I have A is 10, B is 3, and C is 7. We're going to do the same thing. We're going to go through B squared, 3 squared minus 4 times A, which is 10, times C, which is 7. Plug it into your calculator. What happens? Well, 3 squared minus 4 times 10 times 7 is negative 271. So this is negative. This is a negative number, or it's smaller than 0. This is a negative number. It's smaller than 0. It means we will have imaginary solutions. Two imaginary solutions. Because it's negative, we find out that it has to be imaginary, so we expect to have imaginary numbers when we go through this. So we must use that's on them for we know that we would have to use the quadratic formula on this because it is a negative number for our discriminant. That's the only one that'll work. This is not factorable. We couldn't find solutions that way. We do need to use the quadratic formula only. So you need to tell me how many solutions and what type of solutions. Once again, if it is bigger than 0, if it's positive, we're going to say 2 real solutions. If it's exactly 0, we say 1 real solution, and we can either factor it or quadratic formula. And if it's negative, then you have 2 imaginary solutions. No real solutions, but 2 imaginary solutions. Okay. The last thing that you might see that I want you to be aware of is, let's say, I think this one, I'm just make one up, 2x squared minus 3x minus 14. See what happens here. So if I do negative, A is negative 3, excuse me, A is 2, B is negative 3, and C is negative 14. If I do this one, let's say negative squared minus 4 times 2 times negative 14. Don't forget your negative in there like I did last time. If we do that, 3 squared minus 4 times 2 times negative 14. If you do this one, oh, really? And I locked into that one. All right, let's change this quick. Let's say this is a negative 10 instead. So I didn't actually do what I wanted it to do, unfortunately. So pretty wild that that worked out, but okay. Let's change that to a negative 10. Okay, that's better. So if you do it with negative 10, you end up with 89. 89. So what we know with this, it's still positive, but so we're still going to have two real solutions. But what we also can find out from this, if I try and take the square root, if I try and take the square root of 89, it's a decimal. So actually the only way, this means this is not factorable. It won't work out nicely. We're going to get some nasty stuff, which means this one is real solutions, but we also still have to use the quadratic formula only. So those are the two things you need to tell me. How many solutions? Either two real solutions, one real solution, or two imaginary solutions. And then tell me I could factor this or I have to use the quadratic formula. Or you could always use the quadratic formula, but is it factorable or not? And to go back, this is factorable because of this relationship here. Because the square root of 100 is 10, we can actually take the square root and it works out nicely. So try those problems. You don't have to actually get to the solution. So there's going to be 8 problems. You just need to tell me how many solutions and how could you solve them. Okay. I'll answer. Feel free to shoot me an email if you have any questions, and we'll go through some of this on Thursday as well. But make sure you get yesterday's assignment done and today's assignment done by Thursday. Yeah. Have a great day. I'll see you on Thursday.